how do we calculate the average atomic weight of a certain element when given the weights or the atomic masses of all the isotopes of this element and the percent abundances? In this video, we're going to learn how to calculate for the average atomic weights of the isotopes of a certain element so that we can get the average atomic mass of this particular element. Now remember that when you look at the periodic table, our periodic table of elements give us the value of the atomic mass or the atomic weights, and you can see them as the values below the names of the element. So these values that you see that are not whole numbers are what we call the average atomic weights or the average atomic mass of all the isotopes of that particular element. Because it's average, that's why you don't see the masses as whole numbers. Now in this video, we're gonna learn how to calculate for this average atomic masses given the percent abundance of every isotope and of course the exact weight of every isotope. So here on your screen you see problem 1 for carbon element. So carbon has two isotopes. You have carbon 12 and carbon 13. So the mass number of carbon 12 of course is 12 because that means that it has 6 neutrons and 6 protons. That's why it's 12. The exact weight of that isotope is 12 also. And the percent abundance is 98.90%. So that means this is the most common isotope of carbon. On the other hand, this carbon 13 here, carbon 13 has 7 neutrons and 6 protons. That's why it's 13. The exact weight of the isotope of carbon 13 is this value here that you see, and the percent abundance is just 1.10%. So how do we now calculate for the average atomic weight of the element carbon? So please take note of the step-by-step procedure that we're going to do so we can calculate accurately the average atomic weight. So the first thing we need to do is we need to express our percent abundance in decimal. So we need to express this in decimal. The way to do that is we divide each percent abundance by 100. So we can add another column here to the right and we can express the percent in decimal by dividing it by 100. So when we divide 98.90 by 100, that's going to become 0.9890. And when we divide 1.10 divided by 100, that's going to be 0.0110. So now we are already able to express the percent in decimal. So now we're ready to calculate. So what do we need to calculate for the average atomic weight? We need two things. We need the exact weight of every isotope, and we need to multiply that to its percent abundance but already expressed in decimal. So we only need these two things here. So now I'm gonna put the detailed solution here below. So the first thing is we put the mass of carbon 12, so that's exact weight 12.00000 times your decimal percent abundance, which is 0.9890. Okay, so this is the mass, the exact weight of carbon 12 times the decimal. So this is what I'm writing here. Then you add it to the next isotope of carbon, which is carbon 13. So we now put the mass of carbon 13. So that's going to be 13.003355. Multiply it by its percent abundance expressed in decimal. Close that. And now we're ready to input this in the calculator. So we know that 12 times 0.9890 will give us 11.868. I hope that you have your calculator with you so that you can check whether you got the same value as I have gotten here. So 11.68 is the product of this and this. We just limit up to 3 decimal places. And then the next one is 13.003355 times 0.0110. We're going to get 0.014. So after getting the products of every isotope, we are now ready to add the two products that we get. So 11.868 plus 0.014 will give us 12.011. So now we got the average atomic weight of the element carbon as 12.011. Now let's check in the periodic table if we see 12.011 as its average atomic weight. So now let's check the periodic table. We locate carbon, and carbon is here, and you see the mass here as 12.011, which is the value that we got in the computation 12.011. So 12.011. So now you see that again, this is to convince you that the mass that you see on your periodic table is just the average atomic mass of that element, because every element is not the same as its own, because each element has certain number of isotopes and percent abundances, and that's why that's the basis for calculating the average atomic mass. So let's summarize again the process that we did in order to calculate for the average atomic weight. So what we did with a given here of all the isotopes is we converted first the percent into decimal by dividing by 100, and then right after that you go to the calculations. You now multiply the exact weight of every isotope to its percent abundance in decimal. So that's it that you see on the screen. Then the next one, the next isotope, you need to add it. The same thing, add it to the product of the exact weight times the decimal percent abundance. And once you put them in place, may I encourage you to multiply them one by one so you can get the product, because it's possible that your isotopes will not just be two. There are elements with many isotopes. So you get the products of each isotope and then limit it to up to 3 decimal places, and then you add. The moment you get all the products, you now add, and the sum is already the average atomic weight. Okay, so that's it for this video. I hope that you learned something about how to calculate the average atomic weight when given isotopic weights and abundances. This has been Madam Narca saying, don't stop learning, relearning, and unlearning. Till next time, please don't forget to like, share, and subscribe to my YouTube channel, Narcademy. Bye-bye!
Yeah, guys, so subscribe to Narcademy. Subscribe.